If you've ever struggled to get a good solve or found the process too tedious, time consuming, or difficult, the Optimize Solver could be a very useful feature for you. The Optimize Solvers make it easier and faster for both advanced and novice users to obtain a good solve by automatically identifying the set of parameters that give a result that balances uniform removal or polishing time with convergence. We have optimized solvers available for all the different solvers, the standard raster, freeform raster, and rotational, starting in version 8.10 of the Qt.net software. So let's start with an example of a raster solve and then see how the optimized solver can help us. So I have a spot and a metrology map loaded, and I'm on the solve screen. So one thing we introduced with QFlex was this auto option to automatically set the RMS removal error target to 1/10 of the desired removal map standard deviation. And this was a nice improvement over the old Q22 machines, since it often gives us a good starting point for a solve. So if I press play, I get what appears to be a pretty good solve. And the thing I don't know, though, is can I do better? Can I set a lower removal error target without significantly changing the uniform removal and polishing time? So in the past, the only way to know the answer was to manually try several different values. So our starting point here is an RMS removal error target of 3.3 nanometers. So I'm going to uncheck the box and just try a few different values and see how far I can push the solve before my polishing time significantly increases. So my starting point here is an RMS removal error target of 3.3 nanometers, a polishing time of 6 minutes and 42 seconds. So let me try 2 nanometers RMS. So if I do the solve, it still looks pretty good. I have a good solve rating. The time hasn't significantly changed at all. So this looks pretty good. So let me keep going. I'll change this to 1 nanometer RMS. Okay, again, I have a good rating. My dwell map still looks reasonable. The polishing time has only slightly increased to a little over 7 minutes. So this all looks pretty good. So let me see if I can push this even harder, and let me target half a nanometer of, of error. So now when I do a solve, you see I've gone too far. So I'm getting a lot of warnings in the solve checker. Uniform removal is high, and I'm getting warnings about the peak swipe speed and average speed being too low. And you can also see that the polishing time increased significantly. So it went up from a little bit under 7 minutes to now over 25 minutes. So clearly I've added way too much uniform removal by just pushing the solve way too hard. So this was quite tedious and time consuming. I had to try several different values, and I have to now remember which was the optimal value to go back to and use for my final solve. And so this is where the optimized solver comes in. So if I open up the options screen and choose the optimizer for whatever solver I'm using, then I can just click play, and if I'm interested, I can view the details of what the optimizer did. Otherwise, I can just click off this, and I can see that the optimizer came up with the optimal solve. So very close to what I was able to come up with, just over a nanometer RMS of removal error, but without any manual iteration. So I didn't need to change any values, try a bunch of different things. All I had to do was enable the optimizer, click play, and I got the optimal solve. In production, there would be no need to enable this for every solve. So if you wish to use the optimizer for every polishing run on a particular job, you would just enable it here in the process step editor, save the process. And now, if I go to setup runs, And I start to create a polishing run. I'll load in some metrology. And now, since I enabled the optimizer in my process step, when I go to set up the polishing run, all I have to do is click solve. I don't even have to go to the solve screen if I don't want to. And in a single click, I have an optimal solve. Additionally, if I want to enable the optimize solver by default for all new process steps or quick polish runs, I can do that. So I just go to the administration menu, configure application, and then polishing default solve optimizers. And I can enable the optimizer for any or all of the different solver types. So I'm just going to go ahead and enable it for everything. Then click the apply button. And now if I go back to my process and add a new step, and go to the solve screen, you can see that the optimizer is now enabled by default, and I don't have to manually enable it for every new process step. This was a quick demo to show the benefits of the Optimize solver and how to use it. If you'd like to learn more, the applications engineering team can provide more details on the benefits of the optimizers and how they work. It's also worth pointing out that while the details of the rotational solver optimizer are different, the basic concepts are the same, and using it is just as easy as using the raster solver optimizer. So to summarize, the key benefits of the optimized solvers are that you can obtain an optimal solve faster and with fewer clicks. You can often achieve better convergence using the optimized solver. It requires less skill to set up a polishing run. And finally, the optimized solver enables a level of automation. So alongside this feature, we also added an automatic run creation screen where you can specify a spot, a set of metrology files, and the software will then automatically create fully solved polishing runs using the optimized solver. This is an extremely powerful feature that can save your shop a significant amount of time and free up your operators and machines to perform other tasks. So if you'd like to learn more about the optimized solver or the automatic run creation feature, contact one of our applications engineers and they'd be happy to answer any of your questions.